Hey everyone, I'm so excited to greet you on our webinar where we are going to touch a very intriguing topic today. But just before we begin, let me make sure that you can see my screen and hear me well. You can simply drop me a quick message into the GoToMeeting chat box, and this way we figure the things out. Okay, perfect. So let me then quickly introduce myself and we get this broadcasting started. My name is Bogdan and I am a solutions architect here in StarWind. And guys, it's been a long time I didn't conduct webinars, and it's all due to the fact that I was engaged in many projects, many important ones, and I really hope that all of you will see the results very soon, because it's gonna be a lot of announcements and interesting solutions um, during the rest of this year. So you guys stay tuned. Okay, let's then cut to the chase. So on today's webinar, we are going to discuss how to build a true highly availability SQL Server environment. And in the first part, we'll cover SQL Server AlwaysOn failover cluster instances technology. And please note that this webinar is being recorded, and the corresponding video recording should be uploaded to our website and also to our YouTube channel sometime next week. Please also remember to rate our webinar and the end of broadcasting. Okay, so I believe we are good to move on. All right, so let's then quickly overview our today's topics. So first of all, we'll discuss overall SQL Server HA technologies. Then we'll try to understand the SQL Server AlwaysOn approach. Then I'll show you how the traditional implementation of the failover cluster instances looks like. Then we will try to understand how to implement this technology, failover cluster instances, correctly and according to the best practices. Then it's going to be a most interesting part of our webinar, because we are going to see all these things in action within our demo environment. And finally, it's going to be a Q&A session. Okay, let's move on. All right, so now you should see on your screens, all the well-known SQL Server HA and DR technologies, and we are gonna start from the top. So database mirroring was first introduced in SQL Server 2005, and it is actually a real-time long shipping application. So database mirroring provides protection for a single user database to one secondary mirror server. And that server can be connected either synchronously or asynchronously. And the main principle of database mirroring is forwarding transactions from the primary server to the mirror server, which takes only a couple of seconds. However, the main limitations of such technology are: can have only one mirror, mirror database is not readable, must be set up on each database individually. It also doesn't feature automatic failover on multiple databases, and finally, it doesn't replicate SQL logins and jobs to the mirrored instance. Okay, so and then we are moving forward. Log shipping. Just want to say it is really more of a disaster recovery technology than HA technology. Log shipping works by taking a database backup and applying it to one or more remote secondary servers. Storage procedures on the primary database are then used to send transaction log backups to the secondary servers. Actually, log shipping is supported by the SQL Server 2014 Enterprise, Business Intelligence, Standard, and Web editions. The main issues are practically the same. Must be set up on each database individually, no logins and jobs are replicated to the mirrored instance, plus it cannot have synchronized databases. Alright, our next candidate is replication. Guys, frankly speaking, replication shouldn't be considered as an HCI technology as well. However, many database administrators have implemented it exactly for high availability. Basically, replication was designed to provide distributed database access and reporting, but it doesn't allow you to replicate data between SQL Server instances. Another issue is that it has no automatic failover, and also the fact that getting the data back to a failed replication source is too complicated and painful process. Alright guys, all the features that we just discussed help the people to reach quite enough HCI NDR, but they always demand more. Finally, the last two technologies are always-on failover cluster instances and always-on availability groups. The ones that were introduced in SQL Server 2012 and the ones that made all the database admins to reconsider their views on SQL Server high availability and disaster recovery solutions. In fact, we are going to discuss FCIs during today's broadcasting, but let me give you a quick intro on both approaches first. So, what does SQL Server AlwaysOn imply? AlwaysOn is a set of high availability features, including failover cluster instances and availability groups technologies. And the striking difference between them is that FCIs offers instance level protection, while the availability groups can do a database level protection only. Also, a clustered instance has the same binaries installed and configured on two or more cluster nodes. They can be actually either physical or virtual ones. And the database files, in their turn, are sitting on a shared disk. Data disks, on the contrary, can be owned by only one node at a time running the SQL Server instance. It is also called active node. And all other nodes are set to be passive. So, provided a node fails, the disks are moved to one of the passive nodes which start the service, becoming the active node. So when clients connect to the clustered instance, they usually use its virtual network name that in its turn is moved to the active node in order to ensure that all clients are able to connect eventually. All right. With availability groups, two or more copies of the same database are synchronized across multiple nodes. This way you get multiple replicas. And one of those copies is read-write. It can be either read or write, while all other copies are read-only. And to make sure that the clients are connecting to the relevant copy, a virtual network name is used. It is also called listener, which is actually similar to what the cluster virtual network name does. And with an additional connection string property, you can control whether you are hitting the read-write or read-only replica. By the way, availability groups technology doesn't require shared storage, while in case of the failover cluster instances, it is considered as a strong requirement. Alright, but it's all been covered in just 2 words and on the surface. Nevertheless, let's take a look at these technologies in terms of available functionality. Okay, so this info you see on your screens now isn't new, and it's all over the internet. But I believe it should be enough for common understanding of all the key points. In any case, let's then quickly go over each of them. So simply speaking, failover cluster instances is a hybrid of the Windows clustering technology and database mirroring. Therefore, it introduces the corresponding features like support for clustered shared volumes and multi-subnet clustering. It also features faster failover and several failover policies to choose from. Besides that, now it supports TempDB on local drives and gives you improved diagnostic capabilities. So as you can see, all that sounds quite promising, but what about availability groups? Availability groups is actually a replacement for database mirroring, which was deprecated in SQL Server 2012. However, for the time being, this technology offers several advantages over database mirroring. Starting from SQL Server 2014, AlwaysOn availability groups can have up to 8 replicas, 2 of which can be synchronous. It also provides the ability to protect multiple user databases. Plus, you can simultaneously implement synchronous replication for high availability and automatic failover, as well as asynchronous replication for disaster recovery. And support for multiple secondaries. By the way, they can be readable, and built-in high availability management makes it even more attractive. But guys, in my own opinion, the licensing model used for availability groups still keeps some people away from that approach. That's why, my dear friends, don't be so quick to write off failover cluster instance technology, since especially I'll show you how to make such a configuration robust and even more cost efficient. But first, let's see how it's configured traditionally and what issues you may come across, right? So let me then move on to the next slide. Alright, so you just take a look at the diagram on your screens, and I don't think that one of you guys can name this configuration an optimal one, because for example, the first thing which looks intentionally bright is the complexity and high cost of such an infrastructure, and it's all due to the expensive physical SANs and switches. And what I would like to add, I mean, those of you who love all sorts of marketing terms can instantly highlight that these two things dramatically increase TCO of the entire system. Other than that, it would be quite painful to maintain and scale such kind of SQL cluster, not to mention a vendor finger pointing in case something happens to one of the components. Finally, a low return on investment in the cherry on top, as poor performance and redundancy can be really mentioned in this perspective. And whatever they say, you'll never be happy with the performance of the whole system due to latency issues and the surplus in the abstract legs presented. So that's the way these things are going, my friends. But it is still too early to write the epitaph of the FCIs, because I think that maybe they simply put up a proof show configuring FCIs, or maybe they are too boring to approach it correctly. Nevertheless, let's see how it's brewed in StarWind. So we are moving on. Right. So StarWind brings the implementation of SQL Server AlwaysOn FCIs to the qualitatively new level. It delivers data high availability and high performance for SQL environments by utilizing commodity hardware and having very low requirements for the system resources. As you can see on your screens, StarWind vSAN minimal configuration. StarWind vSAN minimal configuration can start with just 2 nodes with no external witness required. It is completely switchless, and it doesn't require any additional equipment to get started, including expensive physical SANs. Yeah. As for the networking part, the network backend itself, that is responsible for storage synchronization, can be represented by just 2 1 gigabit physical network interfaces. And the storage subsystem in its turn is based on either hardware or software arrays, which increases cluster resiliency. RAM and flash are utilized as cache to boost the performance even more. And most probably the greatest thing is that StarWind enables you to choose from different implementation scenarios, including on-premises deployment, hybrid cloud, or completely cloud-based approach. So, I mean, you can achieve a true HA with just a single physical node. And building on existing Azure functionality in SQL Server 2014, for example, StarWind allows you to deploy a database to a Windows Azure virtual machine. And this basically allows users to extend their database environment out of their own hosted environment and on the cloud in the form of Windows Azure. you can even do without any hardware equipment at all in case you deploy the entire cluster in cloud. So what you get is a robust and reliable high availability platform with the wide range of features and proactive support, which is trend now. All right, so that's pretty much it for the presentation itself. So let's then jump into our demo environment in order to see how the system looks like and how everything is configured in details. So guys, just give me a couple of seconds. I'm going to RDP to our demo environment. So please hold on. All right. So let me then introduce our test environment first. So we are gonna talk about two nodes StarWind Virtual SAN cluster uh, that is actually based on Hyper-V hypervisors, and let me then show you everything. So just in order to give you a rough idea on how StarWind works, I'd like to mention that StarWind takes the local disk of each of the physical server, and then it replicates the storage to the partner nodes. And so this way we get HA storage. And talking about the details, I would say that the HA storage can also give you a significant performance increase thanks to the StarWind architecture that enables your clients or virtual machines or roles and other applications to read from all the nodes, from all the cluster participants, right? So it is simply called active configuration, right? So as for the networking, let's then quickly take a look what we do have in this perspective. So as you can see, we have three network interfaces configured and dedicated to StarWind. This one is responsible for processing client connections. This one, we didn't care about it at all actually. And this one that is called sync is doing replication of data, right? So again, as I've mentioned before, according to our minimal system requirements, StarWind requires just two physical ports, to be dedicated exactly to StarWind, right? Right then, so let's then have a look at the failure cluster manager. So over here, we have a couple roles already deployed. So this guy is a simple virtual machine. And here it is SQL Server failure cluster instance that is already deployed. And this one is responsible for providing you with management console. So I mean this place where you monitor and manage your storage. So let me quickly show you how our web management console looks like. So you just give me a second. Honestly speaking, I don't remember the exact IP address that was assigned to our web management console, so let me remember it. So if my memory serves me right, yep, this might be the right one. And as for the credentials, they should be default ones. Okay, looks like I'm disconnecting. It's my colleague actually. Come on. Here we go. So as you can see over here, we have a couple of our test environments already configured in the StarWind management console. So this is the Hyper-V environment, and its two nodes, the SXI one. We also have a VTL product that actually enables you to offload your backups to the cloud, and just to add, we support AWS, Azure, and Google platform. So just for your information, here we have the hybrid cloud already deployed in AWS cloud. So, but we are looking for the Hyper-V environment because we are at one of the Hyper-V nodes currently. Yep, so oops, let me get back to our Star Management Console over here. Yeah, so we have, as you can see over here, we have a couple of virtual devices configured. The one CSV, that is cluster shared volume, and it is actually the exact place where you could store your data, your workload. The witness drive is required for the cluster itself. Yep. And over here you can see the virtual device that where we stored SQL databases and all the related files. Yep. So how it works actually? So you create a single image file on one of the node, you then replicate it to the partner node, and this way it becomes an HA device. Then you simply convert it to the cluster shared volume and present to the cluster eventually. So, as for the StarWind Web Console itself, it also enables you to monitor the, any kind of statistics, including performance ones. It can also allows you to configure some sort of notifications. We can, for example, let me click on the first node. So over here you can see all your settings that you have specified previously, the chat permissions, the access rights that you can configure as well. Over here you will be able to see all the events and logs in case if something happened. And on this top, you can see the IOP statistics. Actually, you can choose from this list the CPU RAM load, CPU load itself, RAM load, total IOP total bandwidth. Yeah. All right, but let's get back to our failover cluster where we have the failover cluster instance already configured. Just let me a couple seconds. I'm gonna get you back. All right. What we're gonna do next? So what I propose to do is to just simulate some kind of power outage on something on one of our Hyper-V nodes, and then we'll be able to make sure that the role itself is migrating correctly, and the database is accessible. So, but just before we do that, let me try to manually migrate it to the partner node. I've chosen best possible node, and it should migrate it to the second Hyper-V node. So as you can see over here, the owner node is already changed. And if we click on resources tab over here, we then can follow all the health statuses and the resources utilization of our SQL Server. So it looks like it has already migrated to the second Hyper-V node. All right. Okay then. What if we try to reach out to SQL Server Management Studio? Actually, this is the exact place where you manage your SQL Server and your databases. Okay, let me then take a look. Alright, so I'm simply clicking connect. Here we go. So here is our SQL Server. I've also created a test database over here. Yeah. So as you can see, it is accessible now, and it seems that everything is up and running. All right, so I believe we are good to start the failover procedure. And in order to do that, I'm going to get back to the first Hyper-V node, make sure that the SQL Server role is now running on the second Hyper-V node. Yep, so this is the exact node I'm going to shut down. So just a second. Alright, so I have simply turned it off. So let's then see. Okay, so as you can see now, our SQL Server role is already migrated to the first node. The storage itself is in painting mode now. Okay, so let's wait a bit. So I believe that you all understood that there will be there still will be a little downtime, even in case you rely on the local storage, because the thing is that in any case the SQL Server servers should be started on the partner node. So alright then, so as you can see again, looks like we have successfully failed over, and in order to make sure that everything is up and running, let me again just a sec. Okay, perfect. So actually that's pretty much it for our live demo technical part, and actually that's how StarWind works and what it does, you know. So now I'm ready to answer all your questions. You know, and they might not be related to our today's topics only. I mean, you're able to ask any questions you are interested in regarding StarWind, regarding all of our products, regarding the functionality, lights, scenes. So I'm gonna give you a couple of minutes to come up with the questions. Right, so it seems I've got the first question from David. David is asking, can StarWind Virtual SAN work with clusters set up in different geographical locations? So the answer is yes. This approach is called stretched clustering, and we do support this. The only things you need is the L2, L3 networks, and that's pretty much it. The next question came from Dan. Dan was asking, if building a 2-node all SATA SSD flash, what NICs would you recommend? How about Intel X550 10 gigabit? You know, it totally depends on your storage configuration. And what I mean is it depends on the RAID type. For example, in case of RAID 10, and in case of RAID 10, I doubt that that your networks would be able to fully saturate the performance of your storage. So, you know, how we usually do, we just to calculate the approximate bandwidth that you can get from your storage. Then we compare it to the bandwidth that you can get from your networking part of the entire system, and then we make a corresponding conclusion. And you know, actually, continue to this topic, to this question, I would say that in case of flash, we recommend to combine SSDs in RAID 5, just in order to provide with the storage efficiency and, you know, decent performance. So in case of RAID 5, I believe that 10 gigabit networking would be good enough. You know, and additionally, uh, I would personally recommend considering Mellanox network interfaces. And the reason is that these cards support RDMA feature. So if you think that it would be beneficial for you to have this feature implemented, then you will rather go with Mellanox instead of Intel. Any other questions, guys? All right, I've got another question. Okay, so what about caching? What would you recommend for SQL Server? Again, it would totally depend on the, I mean, how intensive your SQL Server is. Yep, and we actually support both RAM and flash caching. RAM can be configured in both in write back and write through modes, while the flash cache can be configured in write through mode only. So again, so how we usually do at a pre-sale stage, so we just request some kind of performance reports if in case if you have a live environment, for example, and you are able to get these statistics for us. Then we analyze it and make a decision on what approach you would better go with. Another important thing is the working set. So I mean there are multiple things that should be taken into account just before we uh, come up with the optimal configuration. Another question. Sorry, I missed the beginning half of the webinar. Do you have recording on the web for me to review? Yep. So as I mentioned at the beginning, this webinar is being recorded, and the corresponding video recording you could find on our website as well as on our YouTube channel. So I really hope that it it will be uploaded sometime next week. So you guys just stay tuned. And guys, actually it was just the first part of our webinars. In the next part, we'll cover another SQL Server AlwaysOn technology that is called availability groups. So we'll just understand its architecture and discuss use cases for this approach. And if everything going right, I really hope to record the third part where we'll try to combine these two technologies within a single cluster. So just in order to give you a rough idea on how it will be going on, it's going to be some kind of two-node Hyper-V cluster with the FCI cluster, FCI roles configured, and we are gonna use the availability groups for disaster recovery side. So it should be very interesting. I invite everyone. Right, guys, it seems that we are coming to the end. So I want to say thank you for your attention, and I hope to see you on our next webinars. So please stay tuned, and bye bye.